Alright, here we are on our basic trig review. Just kind of going over a few things we should have touched on last year, but stuff we need to remember for this year. So, the main thing we have to remember here is that we are dealing with these trig ratios, these trig functions, equations, whatever you want to call them. So we have the basic ones. We have sine, cosine, and tangent. Now, the way we deal with them right is the sine, the cosine, and the tangent. And the sine of an angle, or cosine of an angle, is equal to a ratio of the sides of a triangle. We're dealing with those right triangles, right? When we're dealing with the right triangles, there's a connection between two of the sides and an angle. Okay? And that's what these trig ratios are dealing with. That's all they are. So, the sine, so let's get ourselves some angles here. And this angle theta, that's all theta stands for, is an angle. So the sine of this angle is equal to the opposite side over the hypotenuse. Now, we always know what the hypotenuse is, right? The hypotenuse is across from the right angle. That side's always the hypotenuse. The opposite, and as in the cosine, the adjacent, because the cosine is adjacent over hypotenuse, those depend on your vantage point. So for this one, this theta, this would be my opposite, this would be my adjacent. Adjacent because it's touching, opposite because it's across. Whereas if I look at B, if that were my theta, this would be my adjacent because it's touching, and this would be my opposite. So it depends on which one you're dealing with. But those two sides in a ratio are equal to the sine of the angle. Same with the cosine. These two together give us the cosine. And for tangent, it's the opposite over the adjacent. Now, there's an easy way, a mnemonic device that we have to help us with that. It's called SOHCAHTOA. So basically, they take the S from sine, the O from opposite, the H from hypotenuse. That gives us the SO. The sine equals the opposite over the hypotenuse. Same way for the cosine. It's the C and the A and the H. So we get the cosine equals the adjacent over the hypotenuse. And lastly, the TOA, the tangent equals the opposite over the adjacent. So T, O, and A. Okay? So we get SOHCAHTOA. Kind of a shortcut way to remind us of those three different equations that we get. So if we're given pieces, because there's three possibilities, the angle, the side, or the side. If I have two of those, I can figure out the third based off this relationship. And that's what we're using when we look at these. Now the first six are simply looking at the relationship. So the tangent of theta. Theta's right here. So this would be opposite. This would be adjacent. This would be hypotenuse. Tangent is opposite over adjacent, so it would be 12 over 8, which we'd reduce to 3/2. The sine, so this is my hypotenuse, opposite, adjacent. Sine is the, thinking of SOHCAHTOA, sine is the opposite over the hypotenuse, so 9. The opposite over the hypotenuse, so 9 over 15, which we could reduce to 3/5, because we always want to reduce. The cosine is adjacent over hypotenuse, so here's our hypotenuse, our opposite, our adjacent. So it'd be 5 over 13, which we can't reduce. Adjacent over hypotenuse. And there we go. So tangent, there's my opposite, that's my hypotenuse, adjacent. So tangent would be opposite 15 over 8, the adjacent. Okay, the cosine would be So there's opposite, adjacent, hypotenuse. So it would be 3 over 5. And the sine, which is opposite, adjacent, hypotenuse, is opposite over hypotenuse, so 20 over 25, which would reduce to 4/5. So that's all you do for the first one. It's just kind of recognizing that setup. Now what we're going to do is actually use those functions, those equations, to figure out a missing piece. So typically we've got the trig, so sine, cosine, tangent times an angle, or not times actually. That trig of the angle equals that ratio, the side over the other side. Okay. So those are what we're using for this, and that gives us 3 pieces of. And actually, go back to that. That gives us 3 pieces. You either have an angle and a side, or the 2 sides, and you can use those to find any one of these as the missing pieces. So we said we've got the sine of that equals opposite over hypotenuse. We've got the cosine of theta equals adjacent over hypotenuse, and we've got the tangent of theta equals opposite over adjacent. So those are the 3 we choose from. Now, these sides are going to determine which one we use. We don't just get to pick one. It's the side that tells us. So let's look at 7. So there's our angle. That's our reference point. So this would be opposite. This is, can't write adjacent apparently. That's adjacent. That's hypotenuse. So I'm looking for the adjacent. I have the hypotenuse and I have an angle. Well, what connects adjacent and hypotenuse? Cosine. So I'd write the cosine. Do I know my angle? Yeah, it's 56 degrees. Equals the adjacent x over the hypotenuse 3. So now I solve for x. Well, how do I do that? Well, we times both sides by 3. So I get 3 times the cosine of 56 degrees equals x. Now, cosine of 56 degrees is just simply a number. But I need my calculator to figure out what that number is. So then I just go type in my calculator 3 times the cosine of 56. Now, the one thing you have to make sure about is that you are in degrees in a calculator. Calculators that do this can sometimes be in radians or degrees. So mine was correct, so I get 1.67757. I would round to the nearest, thousandth. So we'd probably round up 1.678. Actually, let's round to the nearest hundredth. 1.68. So that's the length of that side. Okay. So now we do number 8. So once again, here's my angle. So this is opposite, this is adjacent, this is hypotenuse, which means it's going to be cosine again. So I go the cosine of 31 degrees, my angle, equals the adjacent x over the hypotenuse 5. So times it by 5, times it by 5. So 5 times the cosine of 31 degrees equals x. So I type that in my calculator. 5 times the cosine of 31 degrees, and I get x equals 4.29 if I round. Okay, so now let's go to number 9. Here's my angle. So I've got the adjacent and the hypotenuse. And apparently every single one of these is going to be cosine. So we set it up. The cosine of 73 degrees equals the adjacent over the hypotenuse. Times both sides by 4. 4 times the cosine of 73 degrees equals x. So x equals 1.17. Number 10. Adjacent, hypotenuse. Wow, that's funny how they all ended up that way. So we get the cosine of 46.9 degrees, so they're not always going to be cosine, equals 3 over x. Now this one's slightly different, so a few more steps. To get rid of that x at the bottom of a fraction, because we don't want to make it rational, so we times by x. Now x times the cosine of 46.9, that's really like a number, so I just divide by it. So those cancel. We're left with x equals 3 divided by the cosine of 46.9. And I just type that in my calculator. 3 divided by the cosine of 46.9 degrees. And that gives me 4.39. Okay? So, that was just using those. And we used all the cosines, so hopefully we have something different now. Oh my goodness. I think every single one of them is cosine. So, same process. Okay, adjacent, hypotenuse. So, cosine of 60 degrees equals 2 over x. So we times by x. And we divide by the cosine of 60 degrees. Kind of combine in steps here. So we end up with x equals 2 divided by the cosine of 60 degrees. Type that into my calculator. And we get x equals 4. Okay, 12, same idea. A hypotenuse. So cosine of 43 degrees equals x over 16. So this one's easier. I just times both sides by 16. And we get 16 times the cosine of 43 degrees gives us 11.7. And there we go for those ones. Okay, now you can also just keep going with it, right? Got a few more. Wonder if we'll have something other than cosine. Looks like it. Yay! So here, I've got my hypotenuse, I've got my opposite side. So opposite over hypotenuse, well, that's sine. So we set it up with the sine. So I go the sine of 34 degrees equals the opposite over the hypotenuse. So I times both sides by 5, so I get 5 times the sine of 34 degrees equals x. So x equals, and I type it in, 5 times the sine of 34 degrees gives me 2.8795, so I rounded up to 8. Okay, 14. That's opposite hypotenuse, so sine. So sine of 40 degrees equals x over 15. Times both sides by 15. I get 15 times the sine of 40 equals x. So x equals 15 times the sine of 40. That's 9.64. Okay, 15. There's opposite, there's hypotenuse. So sine of 41 degrees equals the opposite over the hypotenuse. So this one I've got to times both sides by x. X times the sine of 41 equals 16, so those cancel. Divide by x. We get sine of 41. I want to divide by x, that won't help me out. Divide by the sine of 41. So we get x equals 16 divided by the sine of 41. So that's what I type in, 16 divided by the sine of 41 degrees. And I get 24.39. So 16, got my angle, there's opposite, there's hypotenuse. So still with sine of 47 degrees equals x over 13.4. So you've got to make sure that you don't always put x on the top. You put it if it's the opposite, but when it's the hypotenuse, you put it on the bottom. So times both sides by 13.4, so we get 13.4 sine of 47 equals x. So x equals 13.4 times the sine of 47, 9.8. And there we go with those ones. Okay, now you can even use it to figure out the angle. Okay, to do this, you still use those same setups, but there's an added piece that you're going to have to use that I'll show you. So, here's our reference angle. That would be opposite, that would be hypotenuse, so it's sine. So the sine of our angle is equal to 7 over 11. Now, to get the angle, we have to use the inverse. So we get the inverse of that fraction will give us the angle. And this will be a button on the calculator. So all you have to do is get to this point, and then you type in that, and then the fraction 7 divided by 11, and it'll kick out our degrees. So 39.5 degrees, rounding to the nearest tenth. Okay, here, it's adjacent, right? Hypotenuse, so that's cosine. So I go the cosine of theta equals 4 over 8. Now I could reduce that to 1/2, but I don't have to. So we need to find the inverse of that fraction, and that's going to be our angle. So I go the inverse cosine of 4 divided by 8, or 1/2, equals 60. So my degree right there, 60 degrees. Okay, so we've got the opposite and the adjacent. So we finally get tangent. So the tangent of our angle is equal to the opposite over the adjacent. So I do the inverse tangent of my angle, and that's going to give me, or of my fraction, that gives me my angle. So I do the inverse tangent of 7 divided by 12, and that gives me my angle of 30.26 degrees. Actually, rounded to nearest tenth, so 30.3. 20, same idea. Okay, there's hypotenuse, there's opposite, there's theta. So it would be sine, because sine of theta equals the opposite over the hypotenuse. But I'm looking for the angle, so I do the inverse sine of my fraction, and that gives me my angle of 54.9 degrees equals theta. Okay, so that's it on those ones. That's all you got to do. Now you can combine all that information together to figure out what a full triangle is. Okay, so if I want to figure out this triangle, I need to know what this angle is, because this one's already 90. So to find this one, remember that all three angles add up to 180. So I go 180 minus 33 degrees minus 90. Well, that will just give us 90 minus 33, which equals, what is that going to be, 757? Yeah. So I now know that this angle is 57 degrees. Now I need to figure out a side, right? Well, to do that, okay, we can either find the hypotenuse or we can find that one. I'm going to find the hypotenuse. Okay. Well, actually, maybe I'll find that side. So that would be opposite. That would be adjacent. So with 30, I would go the tangent of 33 degrees equals the opposite over the adjacent. Now, had I used 57, it would have been the tangent of 57 degrees equals the opposite over the adjacent, because I would have switched them, but I don't want to do that one. So I times both sides by 13, and I get 13 times the tangent of 33 degrees equals x. So 13 the tangent of 33, and that gives me 8.44, so 8.4. It's actually a longer decimal, but for this, I would just write 8.4. Now, there's a few different ways I can find this next one. I could use a Pythagorean theorem, right? A squared plus b squared equals c squared. I've got a and b, I could find c. I could do that, but instead I'm going to actually use our trig, since that's what we're practicing. So we want to find that hypotenuse. So I can use either the cosine or the sine. I want to use my original numbers, 33 and 13. So we call that x, and I go adjacent and hypotenuse. So the cosine of 33 degrees would equal 13 over x. So I'm times them by x. So x times the cosine of 33 degrees equals 13 divided by the cosine of 33 degrees. that would give us x. So 13 divided by the cosine of 33 degrees gives us 15.5, and that's my hypotenuse. If I wanted to, I could go 8.4 squared plus 13 squared to get 239.56. Take the square root of that. Now it would give me 15.4777, which we could round to 15.5 easily. Alright, there we go. Actually, make sure you remember this information here, right? Critical that you get that down. There we go. And that SOHCAHTOA can help you remember that.